To give you guys a little background, my name is Seth Burgess. I cover the east side of the state of Connecticut. We have one field engineer per district that's responsible to deal with state forces and oversee hired contractors to do bridge repairs. So when you asked the question, I said, I can't speak for the rest of Connecticut, but I do have a specific project going on right now that could impact anywhere in the state, if anywhere in the country as well. My purpose of the lessons learned is try to predict any potential conflicts that may be encountered down the road when trying to do preservation, rehab, or construction. Those may include additional structures, potential developments allowing commercial or residential to be near our structures. Even the original design aesthetics that are built into the bridges can prevent access, staging areas and storage, pretty much any future impedance that would prevent any access from getting into the structures. In the case I'm going to talk about is utilities. When utilities used to be attached to our bridges, now we have issues getting in due to OSHA clearances and gaining access within the 10 feet of the lines. So the one site I want to discuss, it's two sister bridges that were built in 1964. They carry I-95 northbound and southbound over Route 27 in Stonington. For those of you that are familiar with the area, the Mystic Aquarium is adjacent to the bridges. And it's a major throughway for the Mystic Seaboard area, so there's a lot of recreational summer traffic in that area. There are 5 overhead lines that were attached to the other side of the bridges adjacent to the piers. One of these was Frontier cable. 2 of them were 2 major trunk lines that could not be de-energized for Eversource. One was a fire alert system for the fire department, which I believe was inactive. And running along the bridge was a conduit with DOT power for the highway luminaires. So to give you an idea where it was, right on the seaboard, right in between Boston and New York City. As mentioned, it's a 2-lane highway, I-95, that cuts up right through there, so it is very high with vehicular traffic. Each bridge has an ADT of about 25,000, both northbound and southbound. The picture on the top gives you an aerial of the 2 bridges showing the 2 lanes each direction with Route 27 underneath. The picture on the bottom shows the utilities on the right side that were attached to the bridges. So to give a brief history on how this problem arose. There was a construction project that was initiated years back to do beam end preservation and bearing replacements. Unfortunately, at the time, I don't believe that the scope was properly developed and the utility costs were not incorporated for all the sites. This project closed out in late 2013 when I took my position, and I was informed, we went out and looked at the sites and we could see that the abutments were addressed, Pier 1 was addressed, but Pier 2 still had the lines with no paint, no bearings, nothing done to it. This project included 8 sites total. 4 of them had utilities that, like I said, was not estimated for. So fortunately for 3 of the other sites, the construction department was able to solidify funding. Back in 2012, $1.1 million was the estimate to deal with all 4 sites. And Route 27 was $470,000, approximately half of the total cost on one site alone. Due to the funding limitations, this prevented, construction was unable to get the money, so they were able to do 3 of the 4 sites. And deterioration continued to progress on the concrete substructure, steel beam ends, and bearings. So we're going to go through a couple pictures here. As you can see, the utilities are in very close proximity and can't get in there to do any of the work. On the picture on the left, you have the communication line, fiber line, the 2 major trunk lines, and then on the other side of the pier, there was also another communication line. So trying to get a little bit closer of a picture from down below. The picture on the left, it's hard to see because of the shadow, but that was one of our worst areas of deterioration. And as you can see on the picture on the right, that's what we were dealing with on the inside of the beam ends because a lot of the mag chloride and joint leakage that's occurring on top. So a little close up here from the top. A lot of deterioration between the bottom flange and the web interface. And as John said, the good thing is it just hypothetically, or it accidentally worked out that without preservation, you continue to have the deterioration. And this is exactly what could have been prevented if it was thought of in the beginning of relocating these utilities, or not even attaching them to begin with. This was the worst area of deterioration. So the construction department walked away from this, unfortunately, due to funding constraints. So following the project, bridge safety increased their semi-annual inspections to annual inspections to track this deterioration and make sure it was properly tracked. They informed us of the urgency and stress that we needed to get in there and do something. Almost declared this an emergency, and they wanted to shut down one lane on I-95 until it was addressed. We decided to try to take this on as our own department, and it became the first utility relocation project that was initiated by our department and overseen and administered. So it took approximately 1 year after that point to even get the funding in place. And about a year and a half from that point, utilities were able to break ground this past spring and begin the relocation. They completed about 3 to 4 months later, this past June, at a total cost of $650,000, and the bills continue to come in. We're estimating almost $750,000 5 years after the original estimate of $470,000. The utilities companies were able to relocate in front of the pier and the roadway. Fortunately, after some test bits were conducted, we were able to squeeze it between an existing AT&T duct bank, you can see it in the right picture, and the pier footing with no impact to either. And due to putting it where it was located in that one lane, they were able to do all this work during the day and keep traffic flowing because there's 3 lanes. They were able to keep 1 in each direction. So currently this work's going on as we speak. I didn't have any pictures of the concrete work, but we did it took us about 2 weeks. We did 3 yards of substructure concrete work, Class S repairs, to the 2 piers, Pier 2 on both the structures. Following that, we came in and we have to do 4 full pen beam end. We cut it out, replace it in kind at the fascia beams on the south side where the lower gutter line and the Waterwood Pond and mag chlorides were accessing the beam ends. So as mentioned, up to today, I believe last night was the 3rd full pen weld. We're doing the 4th tonight. Show you a couple pictures of how we're doing it. So due to the deterioration on the bottom flange, we're trying to get in and out as quick as possible. We're doing an L-shape replacement. We're actually, I said in kind, but we're putting a thickened piece of steel because we know this is going to continue to happen until the overlay is done and new joints are installed. So it's quite a bit of work and puts a lot of stress on the contractor we have out there to do this in a short amount of time. So as shown, this was after the first one was conducted the morning after. It was approximately a 14-hour shift. Completed the work on that beam end. So I just want to categorize this into two lessons learned. I think it's important for any bridge projects that go out. I think it's important to predict the impacts on future maintenance, rehab, bridge inspection, any possible access that needs to be gained to the structures, because this will reduce future incidental repair costs. It allows for proper maintenance, ease of access for preservation, and even bridge safety, being able to get in there to conduct their inspections. Somebody else mentioned it earlier, but encompassing all the work at the initial time of rehab, repair, replacement, it's important to take into account. Kicking the can down the road mentality does not help anybody, and if, like John was saying, if preservation is done when it should be, it saves a lot of costs down the road. In this case, we're talking almost $250,000 over a 5-year period just for the utilities to be relocated. And just to give you guys an idea, the estimate for the cost of the concrete and the steel repairs, I'm up to about $120,000 with about 5 weeks of work.
Was there any consideration for plating the beam ends as opposed to cutting out?
We did think of that. In Pier 1, construction had plated over the exterior fascia beam, and we see the water getting behind the plates because they didn't weld all the sides properly, and the area deterioration on the existing steel is allowing water to get behind there. So we were almost debating redoing the work that they had done 5 years ago and going in full replacement. I'm a fan of doing full replacements because you know you're getting it as close to what was existing. You're removing the problem, and by thickening the steel, I was hoping that would extend the life of the structure.
They'll find section loss like what you have there, and basically we'll let them prime it, and then we go back with, if it's a half-inch like web or 1-inch bottom flange, we'll plate the web and the top of the bottom flange and the underside and weld that underside plate to the sole plate and bolt all that together And basically, you're adding 3/4 of an inch or an inch and a half to all the face.
There is additional work that we're doing on the interior beams that are going to involve some plating, and the beam ends we're servicing as well. But the exterior fascia beams, just the amount of deterioration that was there, I preferred to replace it, but we are doing additional plating as well.
More of a comment, just to add to what you've been saying about the plating. I've been dealing with preservation from the design end, and one of the things that I keep seeing, and I want to warn everybody about in the maintenance area, is this idea of just plating over the steel, because oftentimes we're redoing those plating operations because they weren't done properly. There's no consideration for load path, and there's no consideration for trapping water. And as Seth mentioned, in this case, the plate that was installed here actually trapped water because the detail wasn't properly done. The detail may be properly done in some cases, but the load path is not restored properly. And I deal with bridge load ratings in addition to design work, and I see occasionally the plating is not being done properly, and we have to actually take it off and redo it in future preservation projects. So it's important, if you're going to do preservation, to do it properly too.
Thank you.
Thank you, Seth.
The preceding video was produced by the National Center for Pavement Preservation. More information can be found at tsp2.org. That's tsp2.org. Additional support provided by Michigan State University.